Okay, ladies and gentlemen, the topic is going to be function fx. So, how can I define a function? Well, I am going to do a draft here, okay? So, I am going to define a box like have two pipes, one pipe going in and one pipe here going out, okay? So the box inside has the function, and I'm going to call this one fx. If I am going to introduce x1, so the machine is going to start working. I am going to call functions with the name a machine. Actually, a perfect machine. Okay. I introduce x1. The function is going to start working here and it's going to give me one response, which is going to be y1. Then, comma, x2, the working machine, y2. So point is going to be xn. I will introduce xn here, and point y sub n. Okay, so in other words, introducing one point, the machine is going to work and getting only 1 point. Okay, so the set of numbers x is going to be called the domain, and the y set of numbers is going to be called the range. Okay, the range. So the idea here is this: for each particular value x1, I am going to get y1. x2, I am going to call y2. Point, x, the generic term xn, is going to be getting here yn. So, in other words, there is no possibility whatsoever under the function law that with one x, I am going to get two y's. No. One x, one y. So how can I see this one using graphs? Well, let's see. I am going to present to you the most actually easy graph to see, where here I have these points over there, and in the way that those points are going to be a pair of points. So this is x and y, point like this, and I am going to draw a line. If I draw a line here, I know exactly that this is a function called a linear function. So what is the most interesting thing about the linear function? Well, we study those linear functions. We study for years and years and years. In different classes, we mentioned that even if I take 2 points here, between these 2 points over there, I am trying to do my graph as much as I can. So I have 1, 2, 3, and 4. So the vertical here is 4, and 1, 2, 3, and 4. So the horizontal here is also 4. The relationship between vertical and horizontal, we call this one the slope, something that we are going to use. In this situation, for this particular line, we know that there is one particular equation. The equation is called the slope intercept form. I am going to write here the slope intercept form, which is y equal to mx plus b. So this is the equation that I am going to use every time I have to calculate a linear equation, okay? So for our situation over there, well, I have my m, which is going to be my slope, but also I have my b, which is the y-intercept. The y-intercept point here is this point where the line cuts my y-axis. This is the x-axis. So this point is called b. So b in this situation is nothing more than 0. So writing the equation for this particular line here is nothing more than this one. I have y equal to, let me see here, is 4 divided 4, which is 1. Slope is 1. So I don't write the 1 because in algebra we don't write 1. So this is x plus 0, and 0 of course. So this one is nothing more and nothing else than the line y equal x. Okay, so this is called a linear function. To remember you, which is a linear function, I suppose that now you remember which is the slope intercept form. For example, well, if I have, let's do one sample here. I have y equal to 1/2 x plus 2, okay? So I am going to plot in my paper here this one. So I am going to write like this. My y and x axis, and I am going to work now with representing y slope 1/2. So we have here m equal to 1/2. So this is vertical and this is horizontal. So 2 represent to the right because it's positive. 1 represent up because it's positive. From where? From 2. But I have 2 here, so I have 1 and 2. So at 2, my y-intercept. And then I have 2 values, 1 and 2 to the right, and 1 up over there. And I have 1 point. The same, going now 2, 1, I have another point. 2, 1, another point. So now what can I do with this one? Well, I can go with my ruler here and, connecting those points. So I am going to connect those points, and I have the representation. Here is the slope, right? So the slope for any particular linear function is constant, so it's not going to change, and I have the slope clearly represented over there. Very good. So this is 1/2 x plus 2. Very good. So we understood that this is a linear function. What happens if a slope is a negative slope? If a negative slope, the line is going to be in these directions, like this. So those directions are going to be with negative slope. Negative slope. Very good. So let's talk in page number 2 now. So we are in page number 2. let's talk about a particular line. When two lines are going to be parallel. So let's talk about parallel lines, okay? Two lines are going to be parallel only, and if only they have the same slope. In other words, if I have m1, the slope of the line 1 has to be equal to a slope of 2. So in this situation, we will have a slope that are going to be parallel, okay? So coming back to my previous graph here, so how can I represent a slope that is going to be like this, parallel to this one? Well, the slope is going to be y equal to 1/2 x, but now a different here, so -2, so -2. So instead of going here, so I will go from 0, this is my 0, down 1, 2, -2 over there, and I have to build using the same slope. So now I have 2, 1, 2, 1, 2, 1. I have this one, and I can go there, you know, and drawing over there a line that is going to be perfectly parallel over there. So this is going to be a slope. Remember that the particular thing about slope, each line has an unique slope. Okay, so in this situation, both y equal to 1/2 x plus 2 or y equal to 1/2 x minus 2 are parallel lines. Very good. So the condition to be parallel here. What happened with the perpendicular line? Okay, so two lines are going to be perpendicular. Let me finish writing this one. The symbol to be perpendicular in mathematics is like this, okay? So the symbol for this one is like this. Like a T, but up, okay? So this is the symbol to be parallel, okay? So perpendicular lines. When two lines are going to be perpendicular, two lines are going to be perpendicular if, and only if, m1 times m2 is going to be equal to -1. So this is the condition to become perpendicular, okay? So this is the condition to become parallel, okay? So, in other words, let's have my first here line that was 1/2 x plus 2. So what is going to be here a perpendicular line to 1/2 x plus 2? Well, doing this, I have to try with this formula here. 1/2 times a number here that is going to be -1. Well, the only number possible here that is going to be 1/2 is multiplying this one by its inverse. So flopping 2 up, 1 down. And I have to add negative. Why negative? Because we know that positive times negative is going to be negative. And now 1 simplify with 1, 2 simplify with 2, and I will have -1. In other words, y equal to negative 2x is going to be perpendicular to the line number 1. We're going to call this one line number 1. So 1/2 x plus 2. Let's see if this is real, okay? As you can see, I put here that the y-intercept here is going to be 0. So coming back to my graph, right? So a passing point for this line is going to be this one, 0. But then another point, important point here is negative 2. A slope m2 negative 2, and I have to complete. Remember that a slope is always a fraction, okay? Is always a fraction. So I have to complete here by 1. So this is going to be vertical divided horizontal. So 1 to the right, because it's a positive 1 here that I had to complete, and this one down 2 units because it's negative. So I will use this one to complete in my graph the line. So I know that one point is 0. So I have 0 here, right? So now take a look what is going to happen here. I have, let me go and show you my slope. Remember is from the point, I have to go 1 to the right, 1 to the right, and 2 down, 1 and 2. So if I have 1 and 2, I have my third point here. See over there? So now, if I go and draw a line, I will do this one with red. I will have my perpendicular line. Remember that it's going to be called perpendicular because here is going to be 90 degrees. So I did my graph and I get the perpendicular line to the previous one. This one was called number 1 and this one was called number 2. So I have a perpendicular line to number 1 and number 2. Very good. So with this one, we explain about the lines, the functions. But let's try to be more generic than a function. When the functions are going to be, when a function is going to be a function and when it's not going to be a function. So I am going to ask this question. A function, okay? True or false, okay? Well, there is one way to see if it's a function or if it's not a function, okay? So this is called the vertical line test. So if they ask you if this is a function, yes or no, well, you have to run the vertical line test. Of course, every linear function like this is a function, because if I am going to run a virtual non-existent line vertical, I will write here, and I pass this line through the line, always I am going to cut here in one point. If I cut in one point, yes, it's a function. If I am not going to cut in one point, so more than one point, it's not a function. Okay, so let's do some samples about this. So let's write some facts here. All linear functions are functions. Yes, done. Because we prove that the line is going to have only one cutting point. So what happened now? So what happened now if I have something like this? A curve going like this. Well, I have to pass using my vertical line test. If I create here a hypothetical vertical line over there, and I am going to transport this line in an imaginary way through the curve, you can see that the line over there is going to be cut in only one point. So, in other words, this curve is non-linear function, but yes, this is a function. Yes, it is. True. Yes, is a function. So let's go and do another example here. Okay. So let's do here something like this. I know what are you thinking. If I pass a hypothetical line here, vertical line, through the circle here, well, if I transport, I am going to cut in more than one point, like this situation. So let's see what is the meaning of that. Well, take a look. I have x1 here, and I have one y1, and I have another y1 here, which is symmetrical, negative y1. In other words, for one x1, I will have two, one y positive and the other negative. In other words, cutting in two or more points is not a function. It's not a function. Very good. So we are going to stop here because it's more than 25 minutes, and we're going to record another portion of the video.